Which of the following is not a property of trap interrupt in microprocessor? Trap is an interrupt. Say when the system is working and you suddenly take out your pen drive, what will happen? How do the microprocessor will know? So there are certain devices which are connected, peripherals which are connected. The microprocessor need to know. So this comes through various interrupts. And one of the interrupt is trap. The trap has the highest priority. First of all, it is non-maskable. I'll tell you just now that the answer of this question is which is the following is not a property. So C is it uses edge triggered signal. Let me tell you first that the trap is a non-maskable interrupt. That is, whatever is coming, when trap will come, microprocessor has to deal with it. That is, it cannot be disabled or ignored by the microprocessor. Others, RST 7.5 till INTR, they are maskable. They can be disabled, they can be ignored. And this trap is a vectored interrupt, highest priority, non-maskable. But the third one, why it is wrong? Because the trap interrupt uses both level and edge triggered clock, because it is of highest priority among all these interrupts which I showed you. Which of the following is a property of RST 7.5 interrupt? Okay, so these are the interrupts. And when we talk about processor, we have the software interrupts and the hardware interrupts. The trap has the highest priority. It is a non-maskable interrupt. That is, when it comes, the processor has to handle it. And they have different signals, leveled signals, edge triggered signals. Vector address is also there. So which of the following is a property of RST 7.5? This is being asked here. Now the answer here is D. It's vector. It is a vectored address, and the address is 0034. So all these options, that is, first of all, RST 7.5 is a maskable interrupt. That means it can be delayed, it can be disabled or ignored. The priority is second here. You see, this is the highest priority trap. Then we have RST 7.5. It has the second priority, not the third priority. And its vector address is 0034. That is absolutely true. It uses the level triggered signal. Actually, it uses only the edge triggered signal. Only edge triggered signal. The trap uses both of them. Which of the following flag is used to mask INTR interrupt? Okay. So when we talk about the other aspect, when we talk about different flags, trap has the highest probability, priority, sorry. And then we have INTR, the lowest one. We talk about flag when there are certain operations on the ALU. But whenever we talk about the interrupt, there is an interrupt flag. It's not here, which you see. I just showed you because this is the basic flag we talked about. But we are talking about entirely different kind of flag, interrupt flag. If the interrupt flag IF is 1, if this is set that it is equal to 1, the microprocessor will serve any interrupt. The processor ignores the service if the interrupt flag IF is set to 0. If it is equal to 0, then it is reset. Whenever a non-maskable interrupt occurs in 8085 microprocessor, which of the following data line contains the data? Now, interrupts are of two types. First is maskable, second is non-maskable. Non-maskable means they cannot be disabled or ignored. The microprocessor has to cater to it, has to handle it. Trap is one of that kind. And maskable can be ignored, it can be delayed. So the answer here is D, because trap interrupt is a non-maskable interrupt and it has the highest priority among all. So when it happens, its vectored address is 0024, which is in hexadecimal. This is placed where? On the program counter. You know, program counter always have the address of the next instruction to be executed. So this 0024 will be placed in the program counter, and this 0024 is the lower address bus, which is also acting as the data bus. As I told you, AD0 to AD15, this is the whole the address bus, and the 8-bit part is used for the data bus as well. So here the answer is 24H. Which of the following is a non-vectored input? Non-vectored input. Let me give you the answer first, then we'll talk about that. Please remember, the trap is always the highest priority. So we have the software input interrupt and the hardware interrupt. Software interrupt is coming from the software itself, that is the program itself. Hardware is coming from the peripheral devices or the devices which are connected. So vectored and non-vectored means, vectored means it has a proper address. Trap has to be handled. This RST 7.5 till 5.5 and INTR also. But this trap is having the highest priority. It is both edge and level triggered, while the RST 6.5, RST 5.5 and INTR are level triggered. RST 7.5 is edge triggered. The only trap is non-maskable, others are maskable. So this column vectored. So every one is vectored except INTR. So all the vectored have fixed address. See, the program counter will know what address to be placed. But the INTR has a range of address. That is, any address can be taken from here, and that has to be provided by the external device. User will not provide it. System will not provide it. It has to come from the external device. That is why it is a non-vectored input. If it would have been say RST 7.5, so it has a proper address 003C. So trap, RST 7.5, 6.5 are vectored inputs, and they are non-vectored. Which of the following is a software interrupt? See, there are two types of interrupt: hardware interrupt and software interrupt. Hardware interrupt is coming from external signal, that is, some hardware is giving interrupt. Software is a special instruction which comes up as a result of the software itself or the language itself or the program itself. There are certain maskable interrupt that can be delayed or rejected or ignored. There are certain non-maskable interrupt that cannot be delayed or rejected. That is, trap is a maskable interrupt, others are non-maskable. Trap is a non-maskable, others are maskable. Vectored and non-vectored. Now, vectored means where the subroutine starts the location. If the location is known, we call it as a vector. If we don't know the location, the address of the service routine needs to be supplied by the device, then we call it as non-vector. So the answer here is D, RST5. Because software hardware interrupt, there are difference. All these 5.5, 6.5, these are all hardware. Software is 5, 6, 7 like this. I'll just show you the whole series. But let me tell you, trap, INTR, RST 6.5 are the hardware interrupts. But the RST5, this is a software interrupt. Okay. Let me give you an idea about hardware and software interrupts. The hardware interrupt, these are used to handle the asynchronous events. That is, those which are not in they are not synchronous. They are happening anytime. Both are happening anytime. Software interrupts cannot be used to handle asynchronous events. So hardware interrupts, they are requested by the peripheral device or the external device. The software the interrupts, they are requested by microprocessor itself, and through certain programs, certain code, certain instruction. These are software interrupt. Hardware interrupt, after execution of these interrupts, the program counter is not incremented because it is just a hardware interrupt. Okay, once it is executed, it is not incremented. While the software interrupt, after the execution of these interrupts, software program counter is actually incremented. So some hardware interrupts, they are maskable, like we just saw 7.5, 6.5, etc. Software interrupt, all these software interrupts are non-maskable. Though they have high priority, please remember, software interrupts have higher priority than hardware interrupts, but all the software interrupts are non-maskable. While hardware interrupts, some hardware interrupts are maskable, but they have lower priority as compared to the software interrupt. And as I said, the hardware interrupt, it improves the throughput because the devices are giving the instruction or the interrupts. Software interrupt, they don't improve the throughput because the microprocessor will be busy in handling that again and again. And as I said, that this will definitely affect the interrupt control logic, hardware interrupt. The software interrupt won't, this will not affect the interrupt control logic. So let me give you an example of hardware interrupt: trap, RST 7.5, 6.5, 5.5, INTR. These are all hardware interrupts. And RST 1 till 7, 1, 2, 3, 4, 5, 6, 7. These are all software interrupts. What is the vectored address of RST5? So these are the address RST 0 till RST 7, and these are all these software interrupts. The answer is C, and I'll tell you how to find this because there is a proper formula here. The vectored address of RST from 0 to 7, that is, we can call it as RST n can be from 0 to 7. It will be n into 8. That is, if RST 5 you have to calculate, In place of n, put 5, 5 8s are 40, and this is the decimal form. So you have to change it into hexadecimal. That will be 28 in hexadecimal. This is how you find out.